Hi, we are the Perspicuous Pangolins. Welcome to our presentation. We are looking at augmenting the traditional functionality of a prosthetic hand, the 1 degree of freedom of fingers, which allows it to bend that way and in no other way. So you can't combine fingers in other directions and you couldn't bend them backwards. We are looking at implementing the muscular hydrostat functionality of an elephant trunk and its infinite degrees of freedom that it can move in every direction and both extend and retract. And it has no joints that limit its degrees of freedom. It also has a built-in suction element that can manipulate small objects. So this is what we're trying to add to the traditional prosthetic hand.
During the initial phases of designing and prototyping, we wanted to stay on point and make sure that we were following our inspiration based off the elephant trunk, taking up the almost infinite degrees of freedom that an elephant has and implementing our multi-axis movement for our prosthetic fingers, as well as creating extension and retraction and a vacuum grabber. Looking at elephant trunks and their connective tissue and nerves and the trunk being a muscular hydrostat, we wanted to follow similar material by using NinjaFlex and water just to make a softer, more bendable material that we could use. And obviously, size comparison is a big difference between having a large full-size elephant trunk and scaling that down to a small human finger.
While an elephant trunk is obviously driven by muscles, what we are trying to do is go for pneumatic activation, which gives us the additional advantages of extension, retraction, and the vacuum grabber that we talked about earlier. What we are mostly inspired by is the flexible and agile nature of the trunk, but we know that we cannot emulate the gripping forces or the infinite dexterity of an elephant trunk. But what we are trying to compare ourselves to is to improve the range of motion and the gripping force compared to a typical prosthetic hands. And the constraints that we've been facing is the flexibility of the material, which kind of decides how much bendability it has, and the actuation method of using some sort of pneumatic actuation is proving to be a challenge when it comes to scalability. Moving to smaller fingers is something that we need more resources to really expound upon.
And then as Teos was talking about, we are limited to some of our capabilities in terms of manufacturing. We're going to should display 2 demos here today. The first is just range of motion capture. This is wired drawn, obviously, which is just kind of one of our design approaches is we wanted to implement and make sure that we can have multiple degrees of freedom. Moving on from that design, we eventually iterated to a design where we can expand and compress, as well as maintain our entire range of motion, as well as implement the suction grabber at the end of the part. Some of the possible applications for this would be handling of foreign objects, potentially foods, maybe picking up pills and navigating that landscape. But one thing that we wanted to maintain was obviously the dexterous nature, as well as the suction capabilities of the elephant in design.